Alright, this is section 8.1 examples, and so in this problem they want you to find the mean of the sample distribution. Well, mu sub x bar is equal to the mean, which in this case is 52, so that's pretty easy. And the mean, or the standard deviation of the sample distribution, sigma x bar, is equal to sigma divided by the square root of n, which is the sample size up here. So that turns out to be 10 divided by the square root of 21. So for this problem here, I just take 10, turn it on, 10, divide by the square root of 21, and I get 2.18. So 2.182 and some change. And later on here, I'm going to start doing this thing where I'm going to store knit stow alpha A, so I don't have to keep writing that number. So the notation for my stuff when I do that is like that. So that means store alpha A. You see the little arrow and then A. That means I just stored this as alpha A for use later. All right. So that being said, next problem. Okay, here we go. So the length of human pregnancies is approximately normally distributed with a mean of 266 and a standard deviation of 16. So we know that there's normally distributed with a mean of 266, and sigma equal to 16. Now here, what is the probability that a random selected pregnancy, so notice they're not giving you a group here, it's just one pregnancy, lasts less than 260 days. So 260 days would be down here, which really, that's only 6 days less. And if a standard deviation is 16, that's not really that far away from the mean. So I want to find the probability that x, length of the pregnancy, is less than 260. Well, if it's less than, that's this area right here. So I'm going to make a z-score. So z of 260 is going to be equal to 260, take away 266, all over 16. So I'll take the calculator and do that math. So I can 260, that's just negative 6. So negative 6, oh, clear. So negative 6 divided by 16 gives me negative 0.375. All right, so then I want the probability that z is less than negative 0.375. All right, so to do that, I'm just going to go get the table. There it is here. Negative 365. Well, here's negative 3, or 375, and then 75 would be about there. So it's actually halfway between these two, but I'm not going to split hairs. I mean, I'm just going to call it 3557. So this is equal to 0.3557. All right, so that's what I get. So this area here is 0.3557 approximately. I'm going to do it with the calculator. So remember, you can go second, distribution, and I want a normal CDF, so number 2. Remember, I go negative 999, get way down there, comma, negative 0.375. That's the z-score I'm looking for. And then just close that, get the number. And 3538. So if I use a normal CDF, I end up with, well, this is going to be negative 999, comma, negative 0.375. That's how it enters. And that's equal to 0.3538. So that's fine. It is what it is. It's close enough. So I'm good with that. So the probability a pregnancy lasts less than 260 days is about 35%. Let's call it 35%. Okay, close enough, maybe 36. Okay, so that's how you do those. All right, now we have the same thing. All of this up here is mean is that the standard deviation of the population hasn't changed. Suppose the random sample of 20. So now we have a random sample of n equals 20 people. So now I'm having a group of people. So we want me to describe the sample distribution of the mean. Okay, so use of x is the same. And if you remember those slideshows and other things I showed you in those videos, that doesn't change. And then sigma of the mean. So the standard deviation of the means is going to be equal to 16. Well, it's going to be sigma divided by the square root of n. And so in this case, sigma is 16 divided by the square root of 20. So I'm going to go over here and clear. So 16 divided by second square root of 20. And that gives me, that's equal to, well, let's go this way. I'll go this way. Equals 3.577 and some change. So what I have here is I have this distribution. Now, if this was the normal distribution, and this was, if this was 266, and this sigma was equal to, 16, it would look like that. But since this is a sample, we know from that show that if you sample 20, that distribution is going to be a little different. In fact, it's going to be a little pointier than the regular distribution. And this mean is 266 because you remember that those samples targeted the mean, but the standard deviation, sigma x bar, was less, and so in this case it's 3.577 and some change. So that's changing things a little bit. And so now I'm looking for now being less than 260. Or no, I'm not. I'm just going to find those two things. So that's it. So I'm just finding those two scores. So there's the standard deviation of the sample, and then that. All right, let's go to the next one here. All right, so, oh, by the way, I'm going to store this as alpha A again, just so I have it in case I need it here. All right, so what is the probability of the random sample of 12? Okay, so back to this. So now I know that I'm dealing with a sample of 20 people, and I know it's more pointy than the normal curve, but the mean of this is still 266. And I know that the standard deviation of this sample is equal to 3.577 and some change. And I want the mean to be less than 260. So 260, so I'm still looking at that. So I want the probability that x is less than 260 if n is equal to 20. I want to find that. So the first thing I want to do is find z of 260. And that's going to be 260 minus 266 all over a. And I'm going to use a because I don't want to write that big old number again. So I'm going to do negative 6 divided by alpha a. And we get a number. And that's negative 1.677 and some change. So remember, this is 0. My z-score is negative 1.68. And so now the probability that z is less than negative 1.68. And I'm going to go to the table and look that up. Negative 1.6, and then 8 would be this one here. So 0.465. So go back to here. So this is equal to 0.0465. So that this area right here is 0.0465. So the probability that a group of 20 women have an average pregnancy less than 260 days is about 5%. I'm going to round that 4.06 up and around. Okay, so it's about 5%. And so I guess it wouldn't be unusual to have 260 people, right? So there we go. Right. What is the probability that a random sample of 50 pregnancies has a mean gestation period of 260 days or less? Okay, so here we go. We have to know, well, first of all, the probability that X, the gestation period, is less than 260 if N is equal to 50. So now, that's even going to be a skinnier distribution. That's going to be hecka skinny. I don't know what that is. I don't know. I know that the mean is still 266, because that always happens that way, and my 260 is over here. But I'm not sure what the sigma of X bar is here. I'm going to have to go calculate that. So sigma X bar is going to be equal to, so mu of X bar, well, that's 266, and sigma of X bar is equal to 16 divided by the square root of 50. Well, okay, so 16 divided by the square root of 50, 2.26. So 2.262 and some change. So this is 2.262 and some change, and I'm going to store that as A. So the Z of 260 is going to be equal to 260 minus 266 all over my new standard deviation. So negative 6 divided by alpha A. Oops, clear. I didn't store it, so store alpha A. Yeah, okay. Now I take, what was it? Negative 6 divided by alpha A. And so that's negative 2.65. Okay, so I go over to the table. So I'm going to write P that Z is less than negative 2.65 from the table. So I go over here and bust out the table. So negative 2.65, I got to go up a little bit here, a little bit more. So negative 2.65. So that's 1, 2, 3, 4, 5. So 004. All right, so we'll go back to my thing, and this is equal to 0.0040. All right, so what does this mean? So this is the area I'm looking for, and this is 0.0040. So the probability a group of 50 women have an average pregnancy length of 260 days is about 0, or I was going to say 0.4%, so 0.4%. That's not very likely. So that would be unusual if you had that happen. We're going to E. What can you conclude if a random sample of fingerprint resulted in the mean gestation of 260 days or less? Since the probability that X is less than 260 if N is equal to 50 is equal to 0.004, which is less than 0.05. This is unusual. This is unusual. But something else might be happening here. There's a lurking variable. So I actually didn't know why, so I looked it up. I actually went online and found out that there are races that have different gestation periods. Did not know that. So there are some races on our planet for where the gestation period is somewhere between 33 and 37 weeks. So there is a range of 33 to 37 weeks. And you could just happen to be picking from a population where their gestation period is only 33 weeks. Well, what is 33? 33 times 7, 231 days. Well, that's possible. And there might have been some other gestation period. So that's kind of cool. Did not know that. I learned something here. All right, so going to the next one here. All right, so what is the probability that a random sample of size 15, well, now we know n is equal to 15, and I have to go through all that stuff again. The mean gestation period is within 10 days of the mean, okay? So here we have this distribution. 15 wouldn't be all that radically pointy. So here's my 216, or 266. And I'm going to be within 15 both ways. So that's going to put me at, let's see, what do I got? 266 plus 15. So 281. And second enter, let's go back and minus 15 days. So minus 15 days, and that's 251. So I want to, I want to be within, within 10 days, my bad. I thought it said 15 days. 15 is the sample size. So 10 days would make this 276 and then 256. All right, so I want to find the probability that they fall in that range. So that would be the P of 256 is less than X is less than 276 if N equals 15. That's what I'm trying to find. Well, I guess the first thing I'm going to do is find mu of X bar, and we know that's 266. And I'm going to find sigma of X bar, and that's going to be, 16 divided by the square root of 15. And so that's 4.131 dot dot dot, and I'm going to store that as A. So I'm going to store alpha A. Enter. All right, now I want to find Z of 256. So that's 256 minus 266 all over A, which is negative 10 over A. So negative 10, negative 10 divided by alpha A gives me negative 2.42. That's good. So this is negative 2.42. This is 0. And now I'm going to do it anyway, but I really don't have to. So Z of 276 is going to be equal to 276 minus 266 divided by A, which is going to be 10 over A, which is going to be equal to 2.42. So 2.42. So those are my Z scores, and those are my real scores. So here I'm going to find the probability that negative 2.42 is less than Z is less than 2.42. And that's going to be P of Z equal to 2.42 minus P of Z equal to negative 2.42. So I'll go to the table. Where's my table here? Go to the table. So negative 242 is 0078. And I'm going to go back over here. And this is like 0.0078. And then I'm going to go look up 242. Keep practicing this table. Make sure we know how to do it. And 242 is down here. 242 is 9922. So I go over here and I get 0.9922 So I go over here and say, okay, 0.9922 minus 0.0078 gives me that number. So this is equal to 0.9844. So that area in there is 0.9844. So there is a 98% chance. So I'll put it up here. So there is a 98% chance that the group of 15 has a pregnancy within 10 days of the mean. Wow, that's pretty high. Huh. 98% chance. Dang. Okay, surprised again. All right, I think that's it. All right, I'm done.